Hello, everybody. I hope you're all doing well today. We are going to go through this challenge question that's been posted up in the classroom for a little while now. And this question relates to everything that we've been working on as far as functions and linear functions go. So in this problem, we're going to be working on a linear function kind of situation. So let's dive into it. All right, so what have we got here? It says a movie theater is charging $7.50 per ticket. And we have four things that we're gonna do in this problem. So the first thing we're gonna do, it says write an equation to show why the total dollars charged for selling T tickets. So they've given us two variables here. We have Y, which represents the total dollars charged, and we have T, which represents the number of tickets we've sold. And we're gonna write an equation that shows the relationship between those two things. So basically, we're going to be showing how do we calculate the total dollars based on the number of tickets sold. In part B, we're going to make a function table. This is something that we've gotten a lot of practice with over the last month or so. We've seen a lot of function tables, and we've also made some ourselves, practicing calculating those outputs based on inputs. So we're going to make a function table to show the total dollars charged for selling 1, 2, 3, and 4 tickets. In part C, we're going to graph the function. And then in part D, we're going to say whether the function is linear or not. So grab a piece of paper and a pencil, maybe graph paper if you have it, and let's get started. All right, so part A, let's write this equation here. So it says write an equation to show why the total dollars charged for selling T tickets. So we're trying to show why. We're trying to say why, or the total dollars charged, is equal to something. So how do we calculate why based on the number of tickets sold? Take a minute to think about that. Let's say this was you were going to the movie theater with your family maybe. It is $7.50 per ticket. How would you calculate the total dollars you're going to have to pay for however many tickets you're buying? You know, maybe you're buying 2 tickets, maybe you're buying 5 tickets. How would you calculate the calculate the amount of money charged for however many tickets you're buying? So there's a couple ways you could do it. You might think to yourself, excuse me, you might think to yourself, oh, well, I would just add up each ticket. So 750 plus 750 plus 750 plus 750, let's say, if you were doing 4 tickets. So that is absolutely one way you could do it. And a little shortcut way of saying that, right, would be to multiply. So if you are repeatedly adding the same amount, that's just multiplication. So we would do $7.50 per ticket times the number of tickets sold. So let's write that here. We're going to do $7.50 times the number of tickets sold. And we know that when we're multiplying a number and a letter, right, a number and a variable, we usually do not include a multiplication symbol in between them. So we just put the number right next to the variable, and we know that that means multiplication. So this is how I'm writing the equation, but you may have written it a little bit differently. So you may have written y equals 7.5 T, right? 7.50 is the same thing as 7.5. You may or may not have included that dollar symbol. Maybe you did include a multiplication symbol. So maybe you said y equals 750 times T. So maybe you used that little cross symbol for multiplication, or maybe you used the dot symbol. Any way that you choose to write the multiplication really is fine. So not using the multiplication symbol is just the most common way. All right, so we've got our equation here, y equals $7.50 times T times the number of tickets sold. So let's move on to making our function table. So, right, a function table shows input and output. And our variables here, right, are t and y. So our input variable is t, and our output variable is y, the total that we're charged. And we want to know the total dollars charged for selling 1, 2, 3, and 4 tickets. That's what it asks in the problem. So let's get started here. Let's calculate the total dollars charged. Let's calculate our outputs. So you might use a calculator for this if you'd like to, or maybe you feel confident doing it in your head, or you'd like to work it out on paper. So for one ticket, right, it's $7.50 per ticket, and we're buying one ticket. How much are we going to get charged for that? It's going to be $7.50, right? So I'm going to write that as $7.50. Again, maybe you would choose to include the dollar symbol, maybe you don't, maybe you write it as 7.5. Any of those variations is fine. All right, now what about for 2 tickets? Well, we're going to do 2 times 750, or 750 times 2. And when we do that, we get a total of $15. And for 3 tickets, same thing. We're going to multiply 750 times 3 tickets. And for that situation, we're going to have to pay $22.50. And then the last one we were asked to do here, our final input, we're doing 4 tickets, so 750 times 4 tickets will give us $30. $30. All right, and that is our function table. We are showing the total dollars charged for 1, 2, 3, and 4 tickets. All right, now in part C, we're asked to graph the function. So let's give that a try. Now I need to set up my graph. That's the first thing we're going to do. I'm going to actually give my graph a title first. It's always a good idea to give your graph a title, say what the graph is about. So this graph is going to be showing the dollars charged for movie tickets. That's what I'm going to write. And again, it's a title, so there might be different ways that you choose to phrase it. Let's say dollars charged for movie tickets. You might say price for movie tickets, however you want to say it. Right, this is not a multiple choice question. This is a more open-ended question where you have the ability to make some choices about how you want to say things and how you want to show things. All right, so I've got my title here, and now I'm going to set up my axes. I'm going to set up my X and Y axis, or in this case, my T and Y axis. I'm only going to include the positive portions of the axes here, because in this situation, negative numbers don't really make sense, right? We're not going to be selling a negative amount of tickets. We're not going to be paying a negative amount of money. So I'm just going to include my the positive quadrant, the positive portion of the graph here. Do my best to draw some somewhat straight lines. Maybe if you're working on paper, you could get out a ruler or use the edge of a book. And I'm going to label my axes with the variables. So the horizontal axis, the input axis here is T. And the vertical axis, the output, is Y. And I'm also going to label them with a little phrase or description of what the numbers on the axis represent. So, right, that horizontal axis T, that is the number of tickets sold. And then the vertical axis is the amount of money we're paying. So I'll just put some dollars there to show that. We know that where the two axes meet is 0, right? That's our origin. And now I'm going to set up the intervals on the axes. So I'm going to place some markers and some numbers evenly spaced along the axes. And for this, I'm going to think about what numbers I'm going to need to plot. And So to help me think about that, I'm going to take a look at my table. Right, if we take a look at the table here, the t values go from 1 to 4. So I know along my horizontal axis, I'm going to need to get up to 4. And my y values go all the way up to 30. And they're counting by 7.5s, right? That's like the jump we're making each time. So maybe it will be convenient for us to count by 7.5 on our y-axis. Let's give that a try. So on my horizontal axis, let's see, maybe I'll go by 2s here. So this will be, 2 boxes. I just want to space things out evenly, and I also want to use the space I have. So I don't want all of my numbers to be super crowded together into a corner and then have lots of unused space. That's a 4 there, and I'll put a 5 on just because I've got space for it here. And then with my vertical axis, like I said, I think I'm going to try to count by 7.5s because that'll be easiest. So let's do 750 and then 15, 2250. And again, I'm counting by 7.5s here because that's like our base unit, right? That we're charging 750 per ticket. So each time we go up a ticket, we're going up by 7.5. 30, and then again, I've got space for a little bit more here. Let's do 3750. So the way that you set up your graph is going to depend on the situation you're given, the information that you're using. There's lots of decisions to be made when you are constructing or putting together your own graph. All right, so I've got my title, I've got my axes set up and labeled, and I've got the intervals or the numbers set up on my axes. Now I'm ready to actually graph. Let me change colors for this. Let's use purple. So I'm going to use the information on my table to help me get started. So for one ticket, I'm paying $7.50, so I can put a point here. Right, one ticket is $7.50. 2 tickets is $15. 3 tickets is $22.50. 4 tickets is $30. And then right on my graph, I included enough space for another ticket. So let's go ahead and do that, right? If I bought 5 tickets, how much would it cost? Well, adding on another $7.50, it would be $37.50. And again, I'm going to do my best here to connect these all in a straight line. And I'm going to make sure that my straight line goes through the 0 here. Because, right, if we think about this point right here at 0, 0, this is a part of this relationship between tickets and dollars charged. If you buy 0 tickets, you're going to be charged $0, right? So 0, 0 is included on this graph. And I'm going to connect these with a somewhat straight line. Again, you might be able to do a better job if you're doing this on paper with a ruler. And I'm putting the arrow at the end of my purple line here just to show that the relationship continues, right? My graph only went up to 5 tickets, but if I continued counting upwards, right, thinking about more and more tickets, that line would continue upwards. All right, so we wrote our equation, we made a function table, we graphed our function, and then now we're ready to answer the final part here. So part D asks, is this function linear? So take a minute to think about that. What do you think? Is the function linear? Is the function linear? So we can tell this pretty quickly by looking at the graph. If we have graphed this function correctly, we should be able to confidently say that yes, this function is linear because it is a straight line. So I'm going to say yes, it's a linear function. Linear functions are going to be straight lines. right? That's why the word line is hiding inside of linear, because when we're talking about linear things, we're talking about lines. So yes, this is a linear function. We can also tell that this is a linear function by looking at our equation, right? So we discussed how linear equations don't have any exponents or roots on the variable, and the variable is not trapped in the denominator of a fraction. So looking at our equation in part A, we can see that yes, this is a linear function. And we can also tell this by looking at our table, right? If we think back to the very beginning of when we talked about linear functions have a constant rate of change, right? That's what makes it linear. And so looking at our table, we see that there is a constant rate of change. Each time our tickets go up by 1, we see the same change happen each time with our price. So the ticket number goes up by 1, the price goes up by $7.50. The ticket number goes up by 1 again, the price goes up by $7.50 again. So it's the same change happening each time. Every time that our ticket number goes up by 1, our price goes up by $7.50. And we could show that rate of change, that consistent rate of change, like this, right? Comparing the change in the y's to the change in the input, or in this case, t. So the rate of change here that we observe in the table is $7.50 per 1 ticket. And that's consistent throughout the table. All right, so we have answered all 4 parts of this question. Thank you so much for joining me. I hope you found it helpful and interesting. And if you struggled on any parts of this, maybe give the video another watch, and maybe also go back through all of the materials we've been working on in class, all about functions and linear functions. Have a great day.